All right, today we're going to look at 6-6, day 1, maybe. All right, so we're going to solve radical equations. All right, so first thing we're going to do is we're going to start with the steps. So make sure you write these down. So here are the steps. So step 1, get the radical by itself. Step 2, get rid of the radical. Step 3, solve the variable. And these are the steps you use when you only have one radical in the problem. So you might want to clarify that. So we have one radical in the problem. The first step is to get the radical by itself. And then you're going to get rid of the radical, and then you're just going to solve for the variable that's left. So let's do an example. All right, let's do the cubed root of 5x minus 9 equals 11. All right, so step 1, radical is by itself. So it is. The radical is the only thing that's on the left-hand side of the equation. So that's what we mean by radical by itself. The second step is to get rid of the radical. So you look and see what the index number is. So the index number is 3. So I'm going to cube both sides of the equation. So the cube and the cube root will cancel each other out, and we'll just have 5x minus 9. And over here we'll have 11 cubed. All right, so 5x minus 9, 11 cubed is 1331, I think. So now we're going to add 9 to both sides. And we have 5x equals 1340. And then we're going to divide both sides by 5. So I get x is equal to 268. And we can plug it back in to see if it works. So if I take 5 times 268 minus 9, and then take the square root of that number, I get 1331. Take the cubed root of 1331, and I get 11. So I did it right. All right, and let's do one more. Let's do a square root one. So let's do negative 4 square root x minus 6 plus 14 equals negative 22. All right, so our whole goal here is to isolate this and get him all by himself. So the first thing we have to do is get rid of anything that's being added or subtracted. So I'm going to minus 14. That's going to give me negative 4 square root x minus 6 equals negative 36. Now I'm going to, again, my goal is to isolate this. So I need to get rid of negative 4. And negative 4 is connected to it by multiplication. So the opposite is to divide by negative 4. Those cancel out. Divide by negative 4. So now I have the square root of x minus 6 equals 9. So now I want to undo the square root. So I square both sides. Those cancel each other out. So I have x minus 6 equals 81. So now I have plus 6, we get x equals 87. Now I want to get in the habit of checking to see if our answer works. So we'll plug 87 back in. So 87 minus 6 is 81. The square root of 81 is 9. 9 times negative 4 is negative 36. Negative 36 plus 14 is negative 22. So this is indeed the right answer. Right? And so we'll do one more problem. So we have one of each in our notes. So these problems are going to have rational exponents, so they're going to have the fraction exponents. Very similar to what we were doing before, except for there's one extra requirement. So on the exponents, so we'll have like x to some number, and if it's an even number on top over whatever on the bottom, it doesn't matter if the bottom is odd or even, but if the top is even, then this means that there's going to be two solutions. If we have x and then we have odd on the top divided by whatever number's on the bottom, then we're just going to have one solution. All right, so we're going to do one example of each, and then we'll be done with our notes for the day. So let's do 8 parentheses 8x raised to the 4/3 power plus 44 equals 300. All right, so very similar to what we were doing before. We have to isolate the radical, and that's really a radical, right? So we're going to minus 44, and that leaves us with 8x in parentheses raised to the 4/3 power equals, and this would be, what, 256. So now we have this 4/5 power. So the opposite of the 4/5 power is 5/4. So we just do the reciprocal of the power of both sides. But because that top guy is even, that means that we're going to have two solutions. So we're going to have to put plus or minus. And when I say the top guy, I mean this 4 right here. Because this 4 is even, that gives us two solutions. It's kind of like undoing a square root, how you get two solutions, except for this is like to the 4th power. All right, so now we have 8x. These guys just cancel each other out, and they just make 8x to the 1st power. So that's just 8x equals. And then we have 256 raised to the 5/4 power. So first thing I'm going to do is just put it in our calculator and see if it comes out evenly. Or the other thing we could do is we could break it all down. So I get 1,024 when I put that in my calculator, and I have the plus or minus. And then we're going to divide that by 8. Divide that by 8. So x is equal to 1024 divided by 8, which is plus or minus 128. So not too bad. We just have that one extra step to remember, and it's all about the original problem and the exponent that comes from here. All right, so let's do one more problem and we'll be done. All right, we're going to do parentheses x minus 5 raised to the 5/3 power minus 73 equals 170. So again, we want to isolate the radical, so we're going to isolate this guy. So I'm going to plus 73 plus 73. So I'm going to have x minus 5 raised to the 5/3 power equals 243. So now we have the radical guy all by himself, and we're going to raise this to the reciprocal power. So 3/5, 3/5. So because this number right here, this 5, is odd, we're only going to have one solution. So these guys make a 1, so we just have x minus 5 to the 1st power, so just x minus 5 equals, then we need to do 243 raised to the 3/5 power. I get 27, so then we're going to plus 5, plus 5. We get x equals 32. And we can substitute it back in to see if it works. If you do 32 minus 5, you get 27. Raise 27 to the 5 divided by 3 power. You get 243 minus 73, and we get 170. So we know that this is the right answer and it works. All right, so tomorrow we'll do some practice problems like that. We're actually going to do 1 through 31 odd in class. So if for some reason you're going to be absent, that's going to be your assignment, and it's on page 456. All right.